It might be the only port that companies do not block. Yes, this is the DNS port. Attackers can abuse this weakness in firewalls to set up a command and control channel that can be very difficult to detect or even block. We need to set up a server with DNS Cat2 software installed that will listen to the DNS queries from the DNS2 client. Once this is established, we can transmit data and even invoke commands over this channel. As you can see here on the screen, this is the server with DNS2 Cat installed, and this is the client. All the traffic is blocked through the firewall, consider it a corporate firewall, except the DNS traffic on port 53 that is used to resolve URLs. So attackers will leverage this open port here to set up an external command and control center to perform various types of malicious acts. First of all, we need to install the DNS Cat2 server on our Kali machine and then run it. For this purpose here, you just have to copy this. This code will update the repository of Kali and will install Ruby on Rails. Then we'll install the bundler, and then we'll get the DNS Cat2 from GitHub. It will clone it on our Kali machine. Then we will navigate to this directory under the DNS Cat2 folder, and then we'll run bundle install. So let's go here and paste these commands. That's it. Now let's do some listing here. Now you need to run Ruby and invoke the DNS cat2.rb. And here we go. The DNS cat2 server started listening to port 53. Now our server is set up and ready. Now we'll go to install the client part. For the client part, just navigate to downloads.skullsecurity.org/DNS cat2 and install the Windows version. On the client side, I have downloaded that here. I will open command prompt, navigate to the desktop, and invoke this command. So this command is dnscat2.exe, then --DNS space server equal. Now we have to put here the IP of the command and control center. Open a new terminal and let's check the IP. It is 61.144. So by invoking this command, the server that has already presented an interactive shell to remotely control systems will establish this channel over port 53. So encrypted session has been established on port 53, as you can see, and the type is txt cname mx. If you go again, you will see that a new session, new window created, session number 1. Now a connection has been established and the server has been notified of that. To interact with the first session, just type session-i1 and you will see that this is the name of the client here, the victim. Now we have a remote shell to interact with it. Type help and you will see all the commands that you can run remotely, such as upload, download, exec, shutdown, etc. Now let's try to run Notepad remotely. Just type exec notepad.exe and press enter. It will tell you that the request has been sent. And let's go here to the victim and you will see that Notepad has been invoked. With creating each session, you'll be notified here on the server and you can interact accordingly using this command of session-i and the number of the session. Now as you can see, a tunnel has been established between the client and server over port 53. Just to make sure that it's over port 53, we will run Wireshark in order to sniff the traffic and investigate the type of traffic being sent and received. We'll select only wired and then we'll press capture. Now Wireshark is active on the server side. Let's go here again and trigger the same command, and let's open Wireshark. As you can see here, the protocol is mainly DNS. So anyone who's monitoring the victim's network traffic will only see DNS queries. This traffic will of course blend with the noise that is present on many networks. Let's say for example here, while establishing the initial command and control connection, it requires DNS cat client to resolve a text record, which is basically a very normal thing to do. So it will not trigger an alert. So to protect against this type of attack, you should block outbound DNS traffic and only allow trusted DNS servers interaction.